Good morning, ladies and gentlemen.
Morning.
Morning.
Morning. Good afternoon.
The fact that you're sitting here or you're standing and listening to my presentation means that you're alive. When you're alive, it means that you will require energy. And the way you require energy is by eating food. Remember, imagine that you're going to have lunch and you're going to eat this fabulous burger. And you just want to eat it bite by bite and your mouth is already watering. You're really hungry. But what if I tell you that in the burger there are these things investing all over the burger? So then you will think, is this burger safe to eat? Will it make me sick or not? And the worst thing is that bacteria are getting more and more resistant every year. Why? Because we're using the same type of antibiotics over and over again to cure the same thing. So year by year, they're getting more and more resistant. And another scary fact is that the new drugs that are going to the market is getting lower and lower. So we have two situations here. The first one is that bacteria are getting more resistant. And then the second thing is that the antibiotics that we use to cure bacteria are getting less and less. So I live near my home. I live near a river. And the very thing that is very, 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 very interesting is that there's a lot of trash. If you see the amount of trash that has been deposited here is a lot, because the villagers, they just pack their trash inside a plastic bag and they just throw it to the river. And you imagine if they do that for years and how much trash is inside the river. And I dare you, if you take a cup of water and you drink it, tomorrow you will be hospitalized. So this brings my research is the mucus of fish as an antimicrobial agent. Now I forgot to mention that in that river there's a fish living. And how does the fish live in such harsh environment? It is very interesting to study why. Because if we can find out how the fish is able to live in such environment, then maybe we can apply it to our human life. So the problem in this experiment is to use natural means of to treat bacterial infections. And because this experiment is all about fish, I'm going to use catfish. Why catfish? Because catfish is commonly known as the dirtiest fish living in Indonesia. And the two types of catfish that I'm going to use is the Missus gulio and the Clarias gariepius. And the thing in the fish that I'm going to focus is in the fish slime, because fish keepers, they observe that if we take off the fish slime, then the fish is going to be stressed or the fish is going to die. So there must be something very significant in the fish slime. It serves three purposes. The first one is for physical protection, because if we try to catch the fish, it's going to slip easily. That is because the fish slime is so slippery. It's like the fish is trying to escape from the predator. And the second thing is that it reduces friction, because when it swims in the water, it will reduce the amount of energy required for the fish to swim. And the third thing is that it is believed that the fish slime acts as the first line of defense against pathogens, because if a bacteria wants to infect the fish, then the first thing that they have to encounter is going to be the fish slime itself. So the research question is, does the fish mucus possess antimicrobial properties? And if so, does it work bacteriostatically or bactericidally? Bacteriostatic means it just stops bacterial growth. It doesn't kill them. But if it is bactericidal, it will kill the bacteria. So let's go over to how I did the experiment. So the first thing is to, of course, extract the mucus from the fish. So we scrape the skin of the fish very lightly, but when we do that, there's a chance that there might be some skin that I accidentally scrape. So what I have to do is that I have to purify the mixture. So you see that the mucus is mixed well with the skin. So I have to separate it. Using a centrifuge. Using the centrifuge, I'm going to separate the heavier part, which is the skin, and then the lighter part, which is the mucus. So I'm going to take the supernatant and leave the skin and just throw it away. And then of course, for bacteria preparation, we are going to use petri dishes. So the bacteria is placed on the petri dish, and then I'm going to pour a melted agar nutrient. And I'm going to wait for a while, and then what's going to happen is that the nutrient gel is going to solidify into a gel-like consistency. And after that, I'm going to place cylinder cups. Cylinder cups are basically metal cylinders with a hollow center. And I'm going to place it vertically on the agar and place a sample inside the cylinder cup. This is the sample, and the petri dishes are now ready to be incubated overnight. The next morning, I'm going to check for the zone of inhibition, which is the area where bacteria cannot survive. And to prove how the mucus works, I'm going to cut a very small section of the gel from the zone of inhibition and then transfer it into a new petri dish, like so. And of course, it is incubated again and see for growth, for bacteria growth. And I'm going to analyze it on the next few slides. And these are the results that I get. First is from the Mistus guleo extract. And as we can see, what you have to remember in the graph is to actually see that the Mistus guleo extract works better on the Staphylococcus aureus. The positive is the ampicillin, and then the negative is water. For the Clarias gariepius extract, it works slightly better in the E. coli bacteria. For the second experiment where I cut, this is the average results so that we can see it much more clearer. And I'm going to use the 12.5% as the baseline. And as we can see, even though the fish mucus is at 50%, it is like 3/4 of the ampicillin. So if I were to use 100%, then it might outmatch the ampicillin. You see? And then for the second experiment, the first fish mucus and then the second fish mucus all have growth on the first petri dish. And on the second trial, there's also growth. So this indicates a bacteriostatic compound. So from the experiment, I can conclude that the compound in the fish mucus works bacteriostatically, and the Mistus guleo extract is more effective against gram-positive bacteria because it works better with the Staphylococcus aureus, and the Clarias gariepius extract is slightly more effective against gram-negative bacteria because it works better with the E. coli. And my further research is that if we can determine the 3D structure of the protein, then we can study how it works and how it interacts with other proteins. And if we are able to understand that, then we can mass produce it in the drug industry. And if we can mass produce it, then we can buy these drugs in your local drugstores, medicine stores. So remember how we started? We started from something very dirty, something that is filth. It's full of bacteria, it's full of pathogens, but it seems that we can use it to produce antibiotics. So this experiment tells me that I can find healing solutions from such deadly environment. Thank you for listening.